The first parameter is the retention factor or capacity ratio. Ideally, it is supposed to be more than 2 after calculating using this formula. Now, let me show you the meaning of TR and T0. Say we have a chromatogram like this. The middle one is the target peak, and the last peak could be the extraneous compound or the unwanted peak. Of course, we can't forget the solvent peak. So T0 is the elution time for the solvent peak, whereas TR is the retention time for the target peak. Let's assume that the T0 is 0.72 minutes and the TR is 5.2 minutes. So from the calculation, we produce 6.22 for the retention factor. Since the value is more than 2, so the peak quality is considered good as far as the retention factor is concerned. And next, we look at the tailing factor. The perfect value is 1, but it is very difficult to get 1, so it is still okay if you are able to get 2 or less than 2. The formula is a bit complicated. Yes, it is, until we understand all the elements in this formula. The peak height is denoted as h. Then, we form two tangent lines on the peak. 5% above the baseline, we form another line. The left half of this line is denoted as A, whereas the right half B. Then, we find the widths. The width for A is 0.09, whereas for B, 0.08. And now, I'm sure we are ready to find the tailing factor. The calculated value is 0.94, which is around 1. So the peak quality is good enough, and we can say there is no significant tailing. For chromatographic techniques, it is advisable to know the number of theoretical plate, which is the N value. Traditionally, the threshold is 2000. For this N value, the more the merrier. A high N value means high separation efficiency. Good efficiency usually records 4000, 6000, or even more. So for this, we have to understand one more element from the peak. That is the W symbol. This symbol is the total baseline between the two tangent lines. Again, the TR is the retention time for the peak, which is 5.2 minutes. And the W is 0.185. From the calculation, we obtain the N value more than 12,000, which is far above the threshold. That means the separation efficiency is very good. Then how about the resolution? Resolution means how well the peak is separated from the neighboring peak. A good resolution value should be more than 2. The value can be produced using this formula. Now, we have to find the W value and the retention time for the second peak. If the peaks have these retention times, and also these W values, then we are ready to find the resolution value. In this case, the resolution is 5.81, very much more than 2. This indicates that the target peak is well separated from the second peak. Finally, we reach the last parameter, precision. To assess precision, we must have at least 5 readings, and the calculated value should be less than 1%. It can be done using this formula. Let's say we are interested in using the peak area for data processing. Then, we have to gather at least 5 readings for the peak areas. Using the formula, we got the value for precision as 0.59%, and it is less than 1. This means the readings are very consistent for accurate quantification.